Hello students, welcome back. I hope you are doing well. So last time we were discussing chapter 2, Introduction to Java, and we covered evolution of Java, types of Java program, and today we'll be looking at machine language, assembly language, and high level language. Okay, so let's start with machine language. So what is a language? A language is a method through which you can communicate to other persons, isn't it? So if you want to communicate with a computer, you have to use a language, but that language will not be Hindi or English. It will be a different kind of language which is known as machine language or binary language. In this language, sequence of zeros and ones are used. Okay, so you'll just have two digits, that 0 and 1. That is why it is known as binary language, because you are using only two digits. And by combining zeros and ones in different ways, you can give instructions to a computer, and the computer will accordingly perform or execute your instructions. So just as in the decimal form you have 10 digits, so in binary form you have 2 digits. Okay, now each digit is known as a bit. So here I've shown an example of a binary instruction 000010110001. So this is just a sample how a binary instruction might look like. Okay, so this is exactly what the computer needs to understand what you are trying to ask it to do. Okay, now there are many kinds of languages, but broadly they can be classified into high level languages and low level languages. Okay, so machine language is a it's a low level language. Now the languages such as C, C++, Java, okay, there are so many different kinds of computer languages. Okay, so no matter which language you are using for giving the instruction to a computer, ultimately it needs to be converted to machine language, because machine a computer cannot directly understand the Java language or the C language or the C++ language or the Python language. The computer is simply unable to understand it. Okay, so machine language is fundamental to a computer. That is why it is also known as a native language, native to the computer. Okay. Okay, so now when we talk about computers, okay, computer does not only mean our laptop and desktops, okay, it could be any electronic device which has got a chip. Okay, so it could be iPhone device, it could be an Android device, it could be a supercomputer, it could be a mainframe computer, or it could be a any other kind of digital electronics such as washing machine, toaster, microwave, okay, microwave oven. So all these different kinds of digital devices, whenever you speak about digital devices, you must understand that there is an electronic chip, and an electronic chip will have a CPU, okay, and that CPU is, in other words, a computer. Okay, so when I say that different machines use different machine languages, it means that although all these different variety of devices, although they will be using the machine language only, okay, zeros and ones only, but we cannot give the same sequence of zeros and ones to all the devices and expect them to perform uniformly. Okay, why is it so? Well, the reason is that all the devices, they are configured, their hardware is configured differently. Okay, so the machine language for each of them, for each of the different hardwares, will be different. So you must understand this point clearly, that although all the variety of devices use machine language, but there will be minor differences in the way, in the manner in which they understand the language. Okay, so for example, if I have got a sequence of binary instruction, let's say 1001, okay, so this particular instruction 1001 can mean something meaningful, okay, can mean something meaningful to, let's say, an Android device. Whereas if you execute the same sequence, okay, 1001, in a Windows machine, in a desktop machine, okay, that will convey something different, that will convey something different to that particular hardware. Okay, so this is what is meant by different machines use different machine languages. Okay, now I'll be coming to this point later when we will be discussing how Java is platform independent, and how compilers and interpreters work. Okay, so when we discuss compilers, interpreters, and Java, I will come back to this point here. Different machines use different machine languages. So remember, please remember this point, okay? Okay, so you know that machine language is not an easy language. Why? Because imagine you have to write a program in a sequence of zeros and ones. So it will be a difficult process. Okay, it will be a difficult process, and clearly it will be prone to errors, and it will be hard to read and modify. Okay, so to overcome this problem, we came up with another kind of language which is known as assembly language. Okay, so this assembly language is one level above of machine language. So in assembly language you use certain symbols. Okay, now for example, let's say 1001, this particular sequence is the instruction for adding. Okay, you are asking the CPU, the computer, to add. Okay, so this is just an example. Okay, 1001, I'm asking you to assume that 1001 means to add. Okay, you are asking the CPU to add something, add two numbers. Okay, so instead of writing 1001, what you did is you made a certain rule. Okay, that 1001 will be represented by add. 1002 will be represented as sub, that is subtract. Okay, so you made a certain rule, and you mapped a different sequences to certain symbols such as add, subtract, load, compare. Okay, so instead of writing zeros and ones, now what you can do is you can simply write add, subtract. Okay, so now having done this, it is relatively easier to write a program. Let's look at this example. Okay, it's a sample of an assembly language program. I've written add a comma b, and second instruction is move x comma y. Okay, so this simply means that add the value of b to a. Okay, and move xy means that copy the value of y to x. Okay, so you can see how this is simpler than the machine language. Instead of writing sequences of zeros and ones, you have written something which looks like English, isn't it? So this is relatively easier to use and write, but you know the problem that computer can only understand what? It can only understand binary language, that is machine language. So you cannot directly give this instruction to a computer. What needs to be done is you have to convert this particular assembly language into machine language. Okay, and the program which does this conversion is known as assembler. So assembler is a program which converts assembly language into machine language. Okay, so I've represented this in a diagram. See, this is our assembler program. Okay, and its input is assembly language. You give a assembly code to it, and in return it will produce the machine code equivalent of the assembly code. Okay, okay, now coming to high level languages. Okay, so high level languages is very much similar to English language, and hence it is much more easier to use and learn as compared to machine language and assembly language. Machine language is a low level language. Assembly language is a mid level language. Okay, it's neither high level nor completely low level. It's somewhere in between. Okay, but this high level languages such as C, C++, Java, etc. Okay, all these languages are very similar to the English language. Okay, so it is much more simpler to use these languages to write a program. Okay, but now you can see that if you have such programs, again it will not be able to execute directly by the computer. You need a different, you need a mechanism through which you can convert this particular high level language into machine level language, and that conversion is done through a program. Well, actually there are two kinds of programs known as compilers and interpreters. Okay, so a compiler is a program which converts high level language into machine language. Okay, and interpreter is also a program which converts a high level language into machine language. So what is the difference between compiler and interpreter? see the compiler. Okay, first of all, see the program which you write in a high level language is known as source code or source program. Okay, once you have written your source code or your source program, okay, you need to compile it and produce the machine code. Okay, so compiler, what it does is it takes your whole code, okay, it takes your complete code and it converts the entire piece of code all at once. It converts it into machine language. Okay, and machine language is also known as object code. Remember this, machine language is also known as object code. So compiler converts high level language into machine language all at once, the whole program, the entire program. Okay, so once you have written the program in a high level language and then converted it into object code or machine language, then you are ready to execute the program. So when you execute the program will be loaded into the computer's memory and then finally get executed. Okay, and execution of compiled programs is faster than that of interpreted program. Why is that so? Okay, see, in compiler compiles the translates the entire program at once. Okay, that is why the CPU does not need to wait for the conversion to happen. Okay, it does not wait for the conversion to happen, it just goes on executing the instructions line by line because all the instructions are ready in the form of zeros and ones to be executed. Okay, so the compiler, sorry, the CPU does not have to wait. Okay, but in the case of interpreter, okay, let's see the next point in the next slide. In the case of interpreter, you, this is also a translator which converts a high level language into a low level language, but the difference is that it translates a single line at a time. So let's say if you have 100 lines of code, if you have 100 lines of code, it will first of all translate line number 1, and that line number will get executed by the CPU, and then the control will come back to the interpreter, and then the interpreter will translate the second line and give it to the CPU. Okay, and again the CPU will execute that second line of instruction and give the control back to the interpreter. So you can see how this reduces the speed of execution. Okay, because the CPU has to wait for the interpreter to translate the program, whereas in the case of compiler this is not the case. The CPU has got access to the entire program in the form of binary language at once. That is why interpreter is slower than compiler. Remember this. Okay, so in this diagram I've shown how the source code, your source program, goes to a compiler and the compiler produces another piece of code, and that piece of code is the machine language code. Okay, it's the machine code, whereas your source code, it's in the form of high level language. Okay, it's similar to the English language. Okay, so this gets converted to zeros and ones with the help of a compiler. Okay, students, so we'll stop here for today, and tomorrow we'll be discussing what is a we'll be discussing what is the compilation process and how the Java compilation takes place and how is Java program executed. So these topics we'll be covering in the next session. Today we'll stop here. Thank you.